Assalamualaikum and hello everyone. Today our team consisting of myself, Nofra Batusha, Muhammad Faisal, Alia Munira, Farnadira and Siti Zara will be discussing the critical role of effective surface and subsurface water drainage system in residential development. Effective water management is essential to prevent flooding, erosion and other water-related issues, ensuring the longevity and safety of housing project. Our presentation will focus on two significant case studies. The first one is located on part of Mukim Gurun Kuala Muda District, Kedah Darul Aman. The second project is Cadangan Pembangunan Program Khas Perumahan Perwira Negeri Perak. So the first case study is proposed 480 units townhouse low cost, 44 unit townhouse low moderate cost and 148 unit low moderate cost terrace house. This project aims to enhance the availability of affordable housing in that area. The parties involved in this project include CH Teguh Development Setempat as the owner, OSG Architect as the architect, OKS Consulting Engineer as the civil and structural engineer, Pruding PLA as the mechanical and electrical engineer, and Shifa Binis Namran as the main contractor. Each of these parties play a crucial role in ensuring the project's success by following necessary standard and regulation.
Next, we will go through the location and design of the drainage structure. The first picture shown on the right side of the slide is known as surface drainage. It is typically placed along the sides of internal roads and at the perimeter of each unit residential house to collect runoff from the road surfaces and surrounding areas. These drains ensure that water flows away from the houses and towards the main drainage channels. As for the design structure, half precast concrete drain is used and designed to be an open channel drainage system. It is in rectangular shape and has a slight slope with a proper gradient. These U drains then will be connected to main drainage channels that is located along the borderline of the residential area to collect water from the smaller U drains. As for the design, a larger and deeper drain is used with average depth not exceeding 2 meters. These drains also supported with struts to provide additional support and stability to drains. For instance, struts help to prevent the walls of the drain from collapsing inward due to the pressure exerted by the surrounding soil. By reinforcing the drain structure, struts ensure that it maintains its intended shape and structural integrity over time. Struts also helps to distribute the loads exerted on the drain walls more evenly, and this helps to ensure that the drain can withstand the weight of overlying soil, traffic loads or other external forces without experiencing excessive deformation or damage. In addition, manholes and inspection chambers are installed at regular intervals along the drainage network. In residential area, these manholes serve as a crucial access points to underground utility systems. The design of these manholes is a typical circular shape with proper size and diameter so that it can accommodate necessary equipment and personnel while minimizing disruption to the residents. And these manholes are also covered with a frame to provide secure access for maintenance workers.
After that, we can go to the material and equipment used in the drainage system. The material often used for this project is precast concrete drain with two types of drain, which is half drain and U drain. This drain has been made off-site with high quality and very easy to install. Its function is to collect and convey surface water and prevent flooding. This drain also very durable because can withstand heavy loads and harsh maintenance conditions. U drain for this project consists with struts to enhance stability and support correct alignment. Next is manhole. The function of manhole as access point for underground utilities such as sewage and stormwater. The material of manhole is precast concrete, cast iron and HDPE. Manhole also comes with cover that made from cast iron or composite to traffic load resistant. After that, for the equipment used for this project is mini excavator, plate compactor, lazy level and mobile crane. Mini excavator is functioned to digging trench, backfilling, material handling during drainage works. Plate compactor function as soil compaction around pipes and drains, and it will increase soil density and prevent misalignment. After that is the laser level that function to ensure accurate alignment and grading to improve installation efficiency. Mobile crane is function to lift and positions heavy components, so this will bring to efficient handling of material on site.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faisal bin Aziz. Today I would like to present about the maintenance and upkeep of the drainage system. So let's go through case study number 1 first. In this case study, regular cleaning is necessary to prevent obstacle in the drainage. High pressure water jetting or mechanical eroding was commonly used in this cleaning service to remove silt and debris from pipe and channel. So preventive approach such as installing leaf guard and sediment trap near entry point was installed in this drainage to prevent from clogging problem. So according to the site manager, repair and maintenance of broken component is critical to the structural integrity. So any crack in pipe must be repaired immediately to prevent a leak and system failure. Common drainage system issue including blockage, pipe corrosion, and joint failure. Blockage frequently caused by the accumulation of dirt, silt, or organic waste. All of these things can be removed through cleaning and installation of preventive measures such as trap and guard.
Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Zara. Now I will explain about the effectiveness of the system in preventing flood and water damage. First, levees and flood walls. The system definitely may protect the flood as it has high immediate protection. It can hold the water from flowing to the area that needs to prevent it from the water. To prevent the system from breaking, the effective maintenance shall be maintained in order to ensure the system is effective in doing their work. Failure of the levees and flood walls can be found when the water exceeded the level as the water has overflowed the drain. Second one is integrated flood management. The system is combining the structure and non-structure measures such as leverage, stretch, in order to manage the flood that might happen in the future properly. The system approach is really good as it is flexible and can be specified into regional needs. The adoption of integrated flood management definitely helps in resilience improvement to flood and minimize the damage caused by the flood. Lastly, floodplain management and zoning. The floodplain management and zoning system will reduce the risk of flood. It is suitable with the sustainable word that has been talked widely nowadays, as it can develop the sustainability of the land use practices by considering the flood risk in the long term. The ecological benefit also can be provided and lower the peaks of flood as a result of floodplain restoration projects.
In our first case study, the project team encountered several significant issues with drainage system implementation. Firstly, poor alignment was a major problem. Precise alignment is crucial to ensure that each precast concrete piece connects seamlessly. Misalignment can create gaps or uneven surface, hindering water flow and leading to blockage or leaks, which compromise the drainage system functionality. Secondly, capacity and flow management present challenges. The drainage system struggled to handle the expected volume of water runoff, especially during the heavy rain. Drains that were too small quickly reached out capacity, causing overflow onto roads and creating hazardous conditions. Thirdly, construction debris and contamination were significant issues. Debris such as soil, rocks, gravel, and concrete remnants accumulate within the U-drains, causing blockage and reduced water flow capacities. This required frequent maintenance to clear the obstruction. Lastly, inadequate site grading and drainage design were identified. Improper grading led to water pooling around the U-drain or flowing in unexpected direction. This increased the risk of standing water, stagnant condition, and potential pest breeding grounds.
Okay, now let's move to the solutions for the problem that had been encountered in case study 1. First, precise better techniques. Practice the precise alignment techniques are important as it can precisely plan, and enough techniques are needed to position the precast concrete drain section precisely. Then custom fit design of molding each section of precast concrete drain to exact measurement and specification of the drainage project. Then use the high quality sealant and jointing material to guarantee that the joints between sections of the precast concrete drain are watertight. Second, make the capacity of drain larger and manage the flow. First, upsizing drains. It is accommodate a large amount of water runoff. Upsizing drains require enlarging the diameter and capacity of drainage pipe and channels. Then, implement a retention and detention basins. Detention basins are used to temporarily hold water and release it at a controlled amount. Third, implement sediment and erosion control measures and cleaning. Erosion control blankets, silt fences, and sediment traps are the example of sediment and erosion control techniques. Then, cleaning drains after the construction involves getting rid of any dirt, silt, or pollutants that might have been trapped in drain during the construction. The last solution is proper grading and design of drainage. Using this data, a true grading plan that distracts water away from the structures and into drainage system, it is very efficient of drainage systems and lower the flood risk. Then implementing appropriate slope gradients can guarantee that the water moves towards drainage sites without collecting.
Our second case study focus on cadangan pembangunan program khas perumahan perwira negeri Perak, which include the construction of 181 single-story terrace house of Type A, 123 single-story terrace house of Type B on government land in Perak. This project is a low-cost and affordable housing initiative by the nation government to help the low-income groups own homes. The parties involved in this project are owner, Lembaga Perumahan dan Hartanah Perak, architect is Architect Azman Zainul Abidin, civil and structural engineer is DSC and Associates, mechanical and electrical engineer is KYS Namaran, and lastly, mechanical is Energizer Enterprise Namaran. This project demonstrates the importance of collaboration among various stakeholders to achieve the goal of providing affordable housing.
As for the case study project, the area of drainage system covered is only within the internal part of the residential area. For instance, these drains are typically installed around the edges of residential areas. As for the design structure, this project also used precast concrete U-drain, and there are three different sizes of drains, which are PC1 and PC2, which are U-shaped drains with widths of 600mm and 800mm respectively, and PC3, which is a 225mm diameter half-round precast concrete drain. It is rectangular in shape and designed with a slight slope to facilitate the natural flow of water towards the outfall. Proper gradient ensures that water doesn't stagnate, which could lead to blockage or mosquito breeding. Additionally, the drain has an opening at the top that is left open or can be either covered with raised or concrete slabs, which helps preventing large debris from entering and blocking the drainage system. The use of mastic grades depends on the location and design requirements. These covers are typically used to provide a safe and stable surface for pedestrians or vehicles while still allowing access to the drainage systems for maintenance. The water collected in the drain is then directed towards an outfall, such as a larger drainage system or natural water body. Besides, box culvert is placed in front of every unit houses in the residential. It is functioned to control the intake and outtake of water by safely moving water from one side of the road to the other without harming the road or causing erosion, and this helps to reduce risk of floods and damage to the property.
After that, we go to material and equipment used in the drainage system for this project. The material of drain used for this project is precast concrete drain, box culvert, sump, and mild steel grating. For precast concrete drain, has three types of drain, which is half round drain, 600 U drain, and 800 U drain. This drain has been made off-site with high quality and is very easy to install. Those made from strong concrete and durable precast concrete, so it can withstand heavy loads and harsh weather. It also functions to glass and divert surface water to prevent damage. After that is box culvert. It made from rectangular or square precast concrete structures, has been made from strong and durable and also easy to install. Box culvert is essential for stormwater management and as facilitates effective water transfer to reducing flood risk. For sump, it has been made with reinforced concrete or precast concrete. Its function to collect rainwater, runoff and drainage to prevent flooding and property damage. Lastly is mild steel grating. It is made from galvanized mild steel with a low carbon steel with a zinc coating. Its function to cover the sump to keep out debris, animals, and people. It also allows water to flow freely into the sump and will ensure safety and drainage effectiveness. After that, for the equipment used for this project is excavator, trench compactor, concrete mixer, laser level, and rough terrain crane. For excavator, its function to dig trench for a drain or piping works and will navigate various terrains. It also used to remove excess soil and debris on site. After that is trench compactor. Its function for soil compaction around the pipes and drain. So when we use trench compactor, this will increase soil density and prevents misalignment and leaks. After that is concrete mixer. Its function to blend the cement, aggregates, and water to make a concrete. It ensures uniformity and quality of concrete. After that is concrete mixer. Concrete mixer function to enhance durability of concrete elements like manholes and sumps on site. After that is laser level is to ensure proper gradient and alignment of drain, and it also create a reference plane for accurate measurement, so this will prevent water stagnation and flooding at the drain area. Then is rough terrain crane. Its function to lift and positions heavy components in rough terrains and also navigate uneven ground easily. This crane ensure precise placement of drainage infrastructure in the site.
So for case study number 2, there is a form maintenance here, which is a regular inspection, cleaning and debris removal, replace and replacement and repair, and the last one is the monitoring and technology. So for regular inspection, this is to make sure the drainage system stay in a good condition and inside of the drainage don't have any damage. Next is the cleaning and debris removal. This maintenance should do frequently cleaning. This is to prevent the drainage from clog. Next is the repair and replacement. Since this project is quite old, repairing any crack and damage can prevent the drainage from leak and water infiltration. The last one is monitoring and technology. So basically this project use two types, which is water flow sensor and CCTV inspection. So by using both of these methods, it can provide a comprehensive monitoring and maintenance strategy for the drainage system.
Okay, now back to me on the effectiveness of the system to preventing flood and water damage for case study 2. First, stormwater management systems. This system is one of the urban flood prevention systems, as it is the modern system involving the permeable pavement, green roof, rain garden, and retention basins that will reduce the runoff on the surface that causes the urban flood. It will be beneficial towards the environment as the system promotes groundwater recharge and improve the quality of water by filtering out the pollutants. The regular maintenance will be needed in ensuring the effectiveness of the system in the long term. Next, early warning system. The early warning system is a type of preparedness system that will give the early warning that ensure the communities know that the important time to get ready and evacuate, which dramatically lowers the number of fatalities and property damage. This system definitely will be more effective as the public are aware and have the ability and knowledge of the early warning system to respond. For the last one, wetland restoration. Wetland restoration acts as the natural sponge, soaking up extra water and lowering flood peaks. It is very good in reducing the likelihood of flooding. Wetland restoration can be sustained through biodiversity as it enhances water quality and offers wildlife habitats and prevents flooding. It may be complex and need high investment, but as the long-term benefits, it was sufficient enough. Okay, that's all from me. Move to the next presenter.
There are a few problems encountered for the case study 2. Firstly, capacity limitation result in waterlogging, where water accumulates on the surface instead of being channeled away. This causes damage to infrastructure and poses safety risks to residents and visitors. Secondly, blockage in the U-drains were caused by debris like leaves, branches, and trash. This blockage hindered water flow and reduced the system efficiency. Thirdly, corrosion and deterioration of some system were observed. The sump system, with mild diverting, designed to collect excess water, become prone to corrosion and deterioration over time, compromising their functionality. Lastly, inadequate site grading and drainage design led to water pooling around U-drain or flowing in unexpected direction. Poor grading create low spot where water accumulate, increase the risk of standing water, stagnant condition, and potential breeding grounds for pests like mosquitoes.
Okay, now let's move to the solutions for the problem that had been encountered in case study 1. First, precise better techniques. Practice the precise alignment techniques are important as it can precisely plan, and enough techniques are needed to position the precast concrete drain section precisely. Then custom fit design of molding each section of precast concrete drain to exact measurement and specification of the drainage project. Then use the high quality sealant and jointing material to guarantee that the joints between sections of the precast concrete drain are watertight. Second, make the capacity of drain larger and manage the flow. First, upsizing drains. It is accommodate a large amount of water runoff. Upsizing drains require enlarging the diameter and capacity of drainage pipe and channels. Then, implement retention and detention basins. Detention basins are used to temporarily hold water and release it at a controlled amount. Third, implement sediment and erosion control measures and cleaning. Erosion control blankets, silt fences, and sediment traps are the example of sediment and erosion control techniques. Then, cleaning drains after the construction involve getting rid of any dirt, silt, or pollutants that might have been trapped in drain during the construction. The last solution is proper grading and design of drainage. Using this data, a true grading plan that distracts water away from the structures and into drainage system, it is very efficient of drainage systems and lower the flood risk. Then implementing appropriate slope gradients can guarantee that the water moves towards drainage sites without collecting.
Between these two case studies, there are few similarities. First is the material. Both drains are constructed from precast reinforced concrete, which provides durability and strength to handle significant water flow and potential physical impacts. Second, the shape and types of drain. Both are open channel drains designed for stormwater management and efficient water conveyance. Besides, both have a U-shaped cross-section, which helps in efficient water flow and maintenance. Third is the purpose, as they function to collect and convey stormwater away from residential and urban areas, reducing the risk of flooding and preventing waterlogging. Lastly, both drainage system is designed with slope and gradient to facilitate the natural flow of water towards designated outfall points, preventing water stagnation. Meanwhile, for the differences between these two cases is case study 1, the limitation or area covered covers the entire area, extending all the way to the boundary. On the other hand, for case study 2, the limitation or area covered for drainage system covers only within the internal part of the residential house, like at the edges and perimeters along the unit houses. Next, the size and depth of drainage in case study 1 is larger and deeper, particularly at the main drainage channel, as it will transfer the stormwater flow to the outfall. Meanwhile, for case study 2, the size and depth of drainage is smaller and shallower, as it is located at the internal part of residential, such as at the edges and perimeters along the unit houses. Moreover, in case study 1, the main drainage channel include crossbars or support bars that may serve structural purposes or support temporary coverings. In case study 2, the internal drains do not include support bars due to the size of the drain. Furthermore, the cost to construct the drainage system in case study 1 is more expensive than case study 2. And the plant and equipment used to construct the drainage system in case study 1 also are more specialized and bigger than case study 2, which requires more general and smaller plant and equipment. Finally, the drainage system in case study 1 is more prone to clogging than case study 2, which needs to be improved.
Okay, for comparison between two case study, the effectiveness in case study number 1, which is in Gurun Kedah, the depth of drainage and support striking in the drainage system are quite strong, so it can maintain the drainage performance in long term and also prevent the drainage from collapse. For case study number 2, which is Taman Purwira Iskandar, LC U-shaped drain concrete was used, so it have a wide drain area, so this type of drainage can transfer water flow very smooth. Then it can reduce the risk of flooding in this drainage system. So for efficiency for both case study, I think case study number 1 in Gurun Kedah should provide more garbage collection point. This is to reduce the capacity of the drum in the drainage to prevent clogging problem in the drainage. For case study number 2, Taman Perwira Seri Iskandar should upgrade their piping material such as HDPE pipe. This is to improve the performance of the pipe to transfer the water flow without give any damage to the drainage.
We continue to cost analysis. Based on this table, we can see in project 1, the higher total cost is due to extensive drainage requirements involving more U-drain, half-AC drains and manhole. This indicating a complex drainage and large-scale system. In contrast, for project 2 has a lower cost, utilizing fewer U-drains, simpler sump solution and more security and box covers instead of manholes, reflecting the project's smaller scale and cost-effective approach suitable for low-cost housing for this project.
In summary, effective water drainage systems are crucial for preventing flooding and erosion in residential area. The two case studies demonstrate different approach. The Gurun Kedah project feature an extensive and expensive drainage system with larger drain and structural support. They offer excellent performance but require diligent maintenance. On the other hand, the Perwira Negeri Perak project use simpler, cost-effective drainage, focus on a smaller drain, efficiently directing water flow with minimal maintenance needs. Both strategies showcase the importance of tailored drainage system to address specific needs and ensure long-term performance in residential area. I think that's it from us. Thank you for your attention. Bye.